Okay, this one's gonna be a long one. As the title suggests, I'm gonna speed run or maybe walk through the whole paper in one single sitting. So it's gonna be like an hour long. I mean, y'all doing the exam's gonna do this same thing, but for me it's kind of long. I'm not used to uploading such a long video. But you know, if the algorithm treats me right, if I get like 100 views or something, I'll keep uploading whole papers, I guess. I have my calculator ready with me, and yeah, let's start, I guess. A train travels. Oh, I forgot. This is Mechanics 1, International Edexcel, A levels, 2023 January. Alright, let's start. Question 1. Train travels along this rest at station A. Okay, so I guess we have to sketch a speed time graph. So it accelerates uniformly, starting from rest and then until it reaches this. So like this. And then this is T. This is 20. Alright. And then what? Travels at a constant speed of for 3 minutes. So like this. This is T plus 180 because we have to use seconds here. And then the magnitude of the acceleration of the train is twice the magnitude of the deceleration. So it's a slower deceleration. So this would be 3t plus 180. Alright, you might be asking why 3t? Because if we took t time to accelerate to 20 meters per second, and then we have to use twice the time to decelerate back to rest, that means it's 2t. And then stations A and B are 4.8 kilometers apart. Find the value of t. So that means the entire area must be 4.8 because S equals VT, right? That means we have to find the area, and this would be consider this first. This will be T times 20 over 2. This is the area of a triangle, and then the next part is a rectangle, so we plus T, no, this is 180 times 20, and then plus the last triangle would be 2T times 20 over 2, and then this is 4800 meters. Remember to check the units, don't just plug in 4.8. Right, this calculation means we have to do some boring work. Equals 1200, so t is 40 seconds. Part C. Find the acceleration of the train during the first t seconds of its motion. Acceleration equals delta v over delta t, which is 20 over 40 equals 0.5 meters per second squared. Alright, easy enough. Question 2. Two particles A and B are moving in a straight line in the opposite direction towards each other on a smooth horizontal surface when they collide directly. Blah 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 blah. Okay, wait. Let's just draw this out. This is what I usually do. So this is particle A. This has 3m, so like this. Like this. Both are 1.5 meters per second. and then immediately after the collision, direction of motion of A is unchanged, and the difference between the speed of A and B is 1. So I'm assuming B is also moving here. Yeah. That's how collision works. What am I even talking about? Yeah. Okay. So 3m. Wait, no. Let's give it a velocity first. This is v, and then this is v plus 1 or something. Which one is plus 1 though? This one should be plus 1, because if this is plus 1, then that means A is faster than B. Then that means A would hit B again, right? Which doesn't make sense. Okay. Part A, and then the speed of A immediately after the collision. So 3m times 1.5 plus m times negative 1.5, because this is moving in the opposite direction. Alright, I forgot, we have to denote this as the positive direction, equals the momentum after. So 3mv plus mv plus 1. Then we will get 3m equals 4mv plus m. And then we do some dirty work. 4v equals 2, v equals 1/2. Okay, so it's 0.5, and then the speed of B, v plus 1 equals 1.5 meters. This is 1. Yeah. So this is speed of A, and then this is speed of B. Well, basically it's just conservation of momentum. Nothing really too difficult, I think. You do have to think about the logics here though, because it doesn't really give much more information, so you have to figure out what does this mean, what does the difference between speed of A and B mean. Like, does it mean A is faster or B is faster? So here obviously B is faster. And find in terms of m the magnitude of the impulse exerted. So impulse equals the mass and then velocity afterwards minus initial velocity. So that would be 3m Newton seconds. That's the unit. That's it. Okay, question 3. Vectors. Okay. V equals U plus AT equals 14I minus 5J plus negative 4I plus J times 2. Then that would equal to 6I minus 3J. Yeah. MS negative 1. Then since we are trying to find this is the velocity, right? So speed must equal to this, must equal to 6 squared plus 3 squared, or negative 3 squared, whatever, is square root of 45 6 7. Part B. Find the size of the angle between the direction I and the direction of motion. So if we draw it out, this is the I direction and this is the J direction, right? So 6 negative 3 is like this. And then we have to find the size of this angle, right? So theta would equal to, or tangent -1, 3 over 6. And then, wait, this is around 26.6 degrees. Or C, at t time is moving in the direction of vector 2 minus 3j. Find the value of t. So 14I minus 5j plus -4I plus jt equals to 2I minus 3j lambda. Lambda as in like it's a scale, you know. Although I don't think we need lambda here. Let's try it first. So 14 minus 4t I. How would I write it? Let's do this. -5 plus t equals 2 over -3. Like this is scaling. This is ratioing it. Since this vector right here is a 2 to -3 ratio, right? So that means this vector right here must also be a 2 to -3 ratio. That's like the idea I'm using here. Yeah, I think we can solve this. So -42 plus 12t equals -10 plus 2t. And then 10t equals 32t equals 3.2s. Right, question 4. A branch AB. Oh, this is moments, right? I'm not gonna read it, of course. Okay, at least it's all labeled. Does it say? Yeah, it's a non-uniform rod. So shit. This is annoying. Okay, the distance from the point C to the center of mass is x meters. So let's draw it like this. The weight is acting on the center of mass, right? So around this area. And then let's take the moment as C. So we have let's just write these down first. So for the first one, first case, like the 150 newtons case, and then we take the moment as C, and since it is on the point of tilting about C, right? So that means D has no force. Like there's no force applied here, because it's on the point of tilting. That's just what it means. So moment at C, 150 times 1.26 would equal to W x. Yeah. Here there's a 150 newtons, right? Okay. Yeah, I didn't prepare. I didn't do this paper beforehand. I didn't prepare anything, so you know it's gonna be kind of messy. So bear with me. I'll try to explain everything here. So in this first case, there's a 150 newtons. So I'm gonna use another color here. I'm gonna use blue as in the first case. Okay. So 150 newtons, and then there's no force here. There's definitely no force here. And then for the second case, there's 225 newtons here, and then it is on the point of tilting about D. So that means there's a force here, but there's no force at C. So in the second case, 225 newtons downwards. So we take the moment at D, right? Because, you know, we don't want to account for this force. So we take the moment at D. Then that means 0.36 times 225. That means this right here, this clockwise moment would equal to this anti-clockwise moment that is given by W. So would equal to, what is this? Okay, what is this distance? This is this whole thing is 0.9. So this is 0.9 minus x, right? 0.9 minus x times W. Yeah. The difficulty in this question is just how you're gonna get this thing, to get these two equations. If you get these two equations, you have all 8 points. This is 81 equals to 0.9 W minus WX, and then 150, 189. 189 equals to WX. So if we, let's give it names, it's 1 and 2. So if we 1 plus 2, then we have 270 equals 0.9 W. So W must equal to 300 newtons, right? And then that means X must be 189 divided by 300. So X is 0.63. Three points PQR are on a horizontal road where PQR is a straight line. The point Q is between P and R. Vehicle moves from P to Q. Time t equals 12 passes Q. Oh, with constant acceleration, okay. Okay, so initial velocity is u, and then v is 2u. So that means acceleration equals delta v over delta t is 12, and then 2u minus u, so that's u over 12. Okay, and then what's the formula again? V squared minus u squared over 2as, is that? Or I think s equals ut plus 1/2 at squared. I'm not sure. Yeah, I think this is it. Math minor, by the way. Come on, how did I even forget these things? U times 12 plus 1/2 of this times 12 squared, and this is 6 right here. So it's 12 cancelled out 6, so that's 18u 6x. So x equals 3u. Okay, done. I don't wanna have another page open, so right, this is what we're gonna do. As the vehicle passes Q, the acceleration of the vehicle changes instantaneously to 1.5 meters per second squared. Continues to move with a constant acceleration and passes R with speed this or okay, so that means okay, so we know that QR must be 5x, right? So 5x is 15u because we just showed x is 3u. And then what can we use? 3 squared equals u squared plus 2as. Let's try. I'm just trying things out. You know, I don't have a immediate solution to this. But for SUVAT questions, all we can do is just wiggle things out. Just try different things. What is S? Oh, S is 15u, right. So this is 345u, so u is 9. Okay. Yeah. Miraculously, I just solved it. So what I always tell my students is, if you can't really figure it out immediately, or like if you just look at the paper, of course you're not gonna figure it out. You have to try it. You have to write something down. Just write on some blank space and like what you think, and maybe sometimes you get the answer. 14 seconds, okay. So PQ, so the first 12 seconds we pass through PQ, right? So PQ would equal to 6x, which is 18u, which is 18 times 9. 18 times 9, that is 162 meters per second. No, meters, Jesus. And we have to add 2 seconds more, like it passes 2 more seconds here, right? So we have the acceleration. How do I write this? D equals PQ plus 2 times 1 point. S is 18 times 2. Okay, this is messy. I don't want the people watching this video to not understand, so I'm gonna have I'm gonna denote this as S, distance S, and then S is ut plus 1/2 at squared, right? And then we know that at point Q, the speed is 2u, so that means it is 18, and then time is 2 seconds, because you know we're trying to find 14 seconds of distance traveled, and then we already used 12 seconds to travel PQ, so that means we have 2 seconds remaining. And then 1/2 acceleration is 1.5 given here, and then 2 squared. This is 39. So the whole distance, the entire distance is PQ plus S. So that is 162 plus 39. That's 201 meters. Yeah. The thing with doing a whole paper is that I can't prepare that much, and my English is not that good. So bear with me. I'll try. Okay. Okay. This should be a completely free 8 points for you. If you don't get 8 points in this question, you have to study. You really have to study. This is so easy. So what it basically says is it's moving in this direction. I can't draw, come on. This direction, completely horizontal. So what that means is the vertical component of the 500 newtons vector, like this one, must be equal to the vertical component of P. So this one. Writing it down would be 500 sine 40 degrees must equal to P sine alpha degrees. Okay? And then it says the resistance to the motion of the ball as we move along is a constant force of magnitude 900 newtons. And since it is moving at a constant speed, right? So that means how do I draw this? It's kind of messy here. This force right here, the two forces horizontal component must be equal to the resistance that is exerted to the boat by the river. So that means 900 must be equal to 500 cosine 40 degrees plus P cosine 40 degrees. Cosine alpha degrees. Okay? We're solving for this, basically. Yeah, so let's do some math. We get 3 to 1.4 equals P sine alpha. Oops. 500 cosine 40 degrees. So 517 around this cosine alpha. And then if we do 1 divided by 2, we get right hand side is tangent alpha equals to 0.622. Yeah, around that value. So we do inverse tangent of this, we get something around 31.9 degrees. Let's call it 32 degrees. Then that means P must equal to 3 to 1.4 over sine 32 degrees. not comfortable with this answer though. Okay. This is some exam technique right here. If you round up the number in your answer, you have to use the number that you didn't round up before. So, like, you have to get it as accurate as possible. So before that, we had 31.9, right? Or you can use like 31 I forgot what the answer is, but the more accurate it is, the better. Because otherwise, your answer will be will have more error. Is what I'm saying. Let's just round it to 610. The thing is, if I used 321.4 divided by sine 32 degrees, right? Or even 321, then that means there are less significant figures. Less significant figures means that this answer will be let me calculate this. Hold up. I would get 606, right? But the correct answer is closer to 608, right? So the thing is, if you use too little significant figures, your answer would deviate. And of course, you can round 606 into 610, but sometimes it's not the case. If you get 604, you round it up to 600, then that's wrong. So just pay attention to that. When you calculate, when you do calculation, you always use the most accurate answer. Okay. Question 7. This one is, I think it should be harder because elevators are kind of complicated, to be honest. So tension 42. The lift and its content move vertically upwards with an acceleration. Using the model, find in terms of m the combined mass. Okay. Wait, what is the mass of P and Q? Okay, we have to denote something first, I guess. So let's let big M equals combined mass of P and Q, right? I'm not gonna write it all. This is a speed run, so this is a speed run and a walkthrough. I'm not gonna write like I'm really taking the exam. And then we should have F equals MA. So that means 42 mg over 5 plus, or it should be minus, big M plus small m of g equals to big M plus small m times 2g over 5. Yeah, basically the only forces here would be the tension and the weight, and since it is moving upwards, right, so let's call upwards as the positive direction. Then that means F equals MA, M is big M plus small m, and then acceleration is this, and it's accelerating upwards, so it's positive. And then we have upward force, upward tension, and then a downward force is the weight, so it's mg, and then m is big M plus small m again. Yeah, I hope that is understandable. I'm really not good at explaining this shit. And then we have to do math here. So 42 small m, this equals to 7g over 5 big M plus small m. We can move this over here, so that would be 35 over 5, 7 mg equals 7 over 5 big mg. No, I should explain a bit what I'm doing here. If we expand this thing, then you see how this term has a 7 over 5 mg, right? So this has a mg, right? And then this also has a mg. So that means I can move this term over to the left, and it will be a subtraction. And 42 over 5 minus 7 over 5 would be 35 over 5, which is 7. So this whole thing will turn into 7 mg. And then what do we need here? Yeah. Oh yeah. We are finding big M, right? So big M equals to G and G cancels out, and then that would be 5M. So P and Q will have a combined mass of 5M kg. Oh wait, no, I don't have to write kg because you see, it doesn't say what unit it is. Okay, let's use this remaining space for part B. Find in terms of M the mass of box P. The force exerted on box P by box Q is 14. Okay, so there's this force right here. Okay, let's consider only the forces on box P, okay? So box P has a force upwards and a force downwards. The force downwards is PG, which is the weight, right? And then the force upwards is 14 mg over 5. And then these two combined together would equal to P times 2g over 5. This is MA, right? F equals MA, right? So we just have to write this 14 mg over 5 minus PG equals to P times 2g over 5. So solve this, 7 over 5 PG. That means P is 2M. Yeah, should be simple math right here. How many questions do I have left? Oh, that's the last question, okay. Let's continue. Okay, for these kind of questions, of course, draw all the forces. The easiest way is to draw all the forces. And then is there friction? Oh, there is friction. So is it moving down or up? I don't see it. Oh, it's pulled up a rough plane. So that means friction is acting here. Wait, what does this line mean? What is the line of action of the force lies in a vertical plane containing a line of greatest slope of the... What the fuck does that mean? Okay, yeah, let's just ignore that. What the fuck does that even mean? Okay, it's fine. So there's a weight here, and then there's a friction here. So if we make it into this axis right here, then that means this is a 30 degrees. So weight times sine of 30 degrees plus friction equals to 18 times cosine 40 degrees. Cosine 40 degrees has been this and this. So we are using the horizontal component right here. Right. And then what else? Actually, I don't... wait, there is acceleration, so that means it's not equal to that thing. Okay, this is wrong. So that means 18 cosine 40 degrees minus friction minus weight times sine 30 degrees equals to MA, which is 2A. And then let's consider the vertical component. So there's R, and then there's this thing, and then there's the vertical component of weight. So big R plus 18 sine 40 degrees must equal to 2g cosine 30 degrees, right? Yeah. Up arrow equal down arrow. And I think we can solve this first. So using the calc, this should be 2g2 because we know the weight. Yeah, we have to solve this first, and then we have to use the R to find the friction. So 2 times, what is G? G is 10, right? Sine 40 degrees. So this gives R is around 5.75 newtons. Just checking if I'm recording. And then friction is mu times R, so it's 0.3 times 5.75. Then we get 1.7251. I'm just gonna write as many significant figures as I need, I think. And then that means 2A equals to 18 cosine 40 degrees minus 1.7251 minus 20 sine 30 degrees. Way. I got it wrong. Hold up. Wait a minute. What is G? Is G 9.8 or 10? Oh, 9.8. Okay. That's where the calculation went wrong. Yeah, so rookie mistake. G is 9.8. I haven't done this exam in a while. So R should be 5.404. Then wait, no, that's times 0.3. Oh, the decimal point should be here. And then we will get just plug it back in, and then you will get A is 1.18. I'm not gonna calculate. I'm not gonna plug it into a calculator again. It's too tedious. Okay, part B. The points A and B lie on the plane of greatest slope of the plane. Whatever this means. And then where AB is 5 meters, B is above A. Okay, I had to record this again because someone came in my room. Okay. Find the speed of P as it passes through B. So this is just Sulfat equation. We don't have to think about it in that scenario. We can just imagine a point passing through A with this and with this speed with 2 meters per second, and then at point B this should be 5 meters, and then we also have acceleration here, right? So yeah, this question is a Sulfat equation. We don't have to think in a way that is more complicated. We don't have to think think about the slope. Is basically what I'm talking about. So v squared plus equals u squared plus 2as. This is the easiest way to find it, I think. 2 squared plus 2 times 1.18 times 5. And then we will get v is square root of 4 plus 1.8. 3.97. So that's like 4. Let's just call it 4. And then part C, the force is removed at the instance it passes through B. As a result, it comes to rest at point C. Okay, so that means we're finding point C. wait, no, determine whether P will remain at rest at C. So we're trying to see if the friction is enough. So we have to refer back to this. Oh god damn it, we have to use this ugly diagram again. I'm gonna erase all the dirty work. So let's assume there's no force here. That means the only force is this and then the friction. So we're trying to figure out if the friction is enough to cancel out this component of the weights. So well, let's just do it here. Part C. What was the friction? Friction was... Wait, do I have to calculate it all again? Yeah, since here's the thing, since 18 newtons is removed, that means R is different. That means we have to calculate R again. So here, R must equal to 2 times 9.8 times, this is 30 degrees, so this is cosine 30 degrees. .974 around that area. So you will see that the R is much larger, right? That's because the 18 newtons force has been removed. So R is this. So that means friction equals to 0.3 times R is around 5.1. Okay, let's use as many significant figures as possible, right? That's literally what I said, and I have just broken that rule. So friction is this, and then the horizontal component of the weight is 2 times 9.8 times sine 30 degrees. So since sine 30 is 1/2, right? So it's easily just 9.8. Okay, so since let me draw it out. Since this is 9.8 and then this is 5.09, this arrow is clearly bigger than this arrow, right? So that means the sum force is pointing downwards. So that means there's a force here, right? Meaning there will be an acceleration. That means it will definitely move down. How do I write this? Since 9.8 is larger than 5.09, so there is an acceleration downwards, down the slope. So it doesn't come to rest. It does not remain at rest at C, at point C. Yeah, that's it. Okay, how long did it take? I don't know.